So this is calculus. We're on topic 4.2, position, velocity, and acceleration. So the check your understanding problems. A position of a yo-yo is given by h of t equals t cubed minus 6t squared plus 5t plus 30, where t is measured in seconds and h is measured in inches. H of t is measured in inches. Find the average velocity over the first 4 seconds. So average velocity means rate of change or slope. And so over the first 4 seconds, so that's from 0 to 4. And so I need to know what the h, so I need h of 4 minus h of 0 divided by 4 minus 0. I'm going to go this way. H of 0 is 30. And my denominator will be 4. And then if I plug in 4, and I'm going to let my calculator handle that one for me. And so I can do a couple of things, but I'm going to put the equation in. It's the easiest thing for me is to put it in once, just in case I need it again. So I'm going to have t to the third power minus 6t squared plus 5t plus 30. So there's my equation. Just double checking that I typed everything correctly. I did. Cool. And then I could do alpha and trace, and that pops my menu. It was my first equation, evaluated at 4. So I get 18. And if I want to choose my calculator in a different way to do the problem, I'm going to go ahead and clear that out. So what I did instead is I did y, so I pushed alpha and trace, and there was y1, and then I did of 4, and hit enter. Okay, very basic, not very exciting kind of a calculation. I could have done the following: 4 cubed minus 6 times 4, minus 6 times 4 squared plus 5 times 4 plus 30. I could have done it like this and still gotten 18. Whichever one floats your boat. Either way, you have to enter the big giant thing. All right, so then I've got 18 minus 30, which is negative 12 over 4, which is negative 3. Average velocity, t is measured in seconds, and h of t is measured in inches. So this is inches per second. Then it wants me to find the instantaneous velocity at 3, which means I need the derivative. So h prime of t equals 3t squared minus 12t. That is not a 12. Plus 5, and then I need to evaluate it at 3. And so I'm imagining now I don't have a calculator. I get 27 minus 36 plus 5, which is negative 4. Again, inches per second. Okay. And that's that. So average velocity is, and then this went backwards, so I should have planned better. But average velocity, instantaneous velocity. Units on both are the same. Okay. The position of an object is given by x of t equals the cosine of 3t minus sine of 4t. Find the acceleration. So this is my position. So sometimes it's s of t. In this case, it's x of t because we're moving on the x-axis. But x prime of t, which is equal to v of t, is equal to the derivative of cosine is negative sine of 3t times the inside, minus the derivative of sine is cosine of 4t times the inside, which, cleaning up just a little bit, we get negative 3 sine of 3t minus 4 cosine of 4t is my velocity. And then continuing, x double prime of t, which is equal to v prime of t, which is equal to a of t, done, huh, is equal to, and we're going to go underneath, negative 3 cosine of 3t times the inside, derivative of the inside, minus 4 sine of 4t times the derivative of the inside. We're cleaning up just a little bit. A of t equals negative 9 cosine of 3t minus 16, wait, derivative of cosine, this should be positive, 16 sine of 4t. Okay, so we wanted the acceleration at time 0. So a of 0 equals, let me use a different color for that. And put cosine at 0 was 1. Sine at 0 is 0. And that's it. Acceleration is negative 9, and it doesn't tell me anything about my units. So I'm going to go units per time squared, whatever that is. Doesn't give me any information, but I've got some sort of unit of length divided by time twice. All right, number 3. Okay. All right, number 3. So the graph of v of t is shown below, representing the velocity of an object moving on a line over the time interval from 0 to 8. When is the object at rest? Justify your answer. So the object is at rest when v of t equals 0. So it's equal to 0 at 5 and 8. Since 8 is included, and those are the two places where it's equal to 0. At time 2 is the object speeding up or slowing down. So in order to determine that, speeding up or slowing down, I need to compare I need the sign of the velocity and the sign of the acceleration. So at time 2, velocity is positive. So v of 2 is greater than 0. I don't care what it is, it's greater than 0. Okay. And a of t of 2 is the slope, and that's also positive. It's also greater than 0, so they have the same sign. So speeding up, that was a lot of ease. So it's speeding up because acceleration and velocity are both positive. That's it. All right. Let v of t equal that equation. Represent that v of t equal to 1 divided by pi plus sine of 3t. Represent the velocity of an object moving along a line. On the interval from pi halves to pi, what is the velocities? What is the velocity when the acceleration is 3? Okay. That is a tricky little question. But let's see what we can do with it. V prime of t is equal to the acceleration. And so the derivative of 1 over pi is going to be 0. That's just a number. And the derivative of sine is cosine of 3t times the inside function, which is 3 cosine of 3t. Okay. The acceleration is 3. So 3 equals 3 cosine of 3t. And so really we're asking when is cosine of 3t equal to 1, dividing both sides by 3. So that cosine is equal to 1 at 0, but 0 is not in this interval. And at 2 pi, and that's a little confusing, but not t equals these numbers, 3t equals these numbers. So 3t equals 0. So t is 0, and that's not in the interval. And 3t equals 2 pi is t equals 2 pi thirds, and 2 pi thirds is between pi halves and pi. So in between pi halves, if we think our unit circle, this is pi halves, and this is pi, right? Pi halves and pi. And so 3 pi halves, 2/3 pi, since pi 6, 1/3, 2/3 pi is right here. So yeah, 2/3 pi is over here. So that's not the answer. T equals 2/3 pi, but that's not the answer. Crap. What's my answer? What am I supposed to do? So, I see more paper. So the velocity when the acceleration is 3. So the acceleration is 3 at time equals 2/3. What is the velocity? So v of t, we want v of 2/3. V of 2 pi thirds. And so there's my original equation. 1 over pi plus 3 times the sine. Wait, no, not 3 times the sine. Sine of 3 times 2 pi thirds. Not 3, solve it. Which means I've got 1 over pi plus the sine of 2 pi. And sine of 2 pi, we're all the way around our circle, and sine is 0. So because that's going to go away. So 1 over pi is my answer. So the question is a little strange. On the interval, what is the velocity when the acceleration is 3? So what I had to do, walk you through it, is I had to find the acceleration. I took the derivative, and I found the acceleration. I set the acceleration equal to 3. I divided both sides by 3. So then the cosine of 3t was 1. Cosine is equal to 1 at 0 and pi halves. And so 3t needs to equal 0 or pi halves. It equals at time 0, but time 0 is not in this interval, so I threw that one out. 3t equals 2 pi at 2 pi thirds. That is in that interval, so this is the answer I care about. Then I took that answer, which is when the acceleration is 3. And said, okay, so what is the velocity when the acceleration is 3? Now. Okay. But I will talk to you guys soon.